Hello all. In this video we're going to discuss a problem on linked list, that is reverse a linked list. Let's see the example. So this is the given linked list. Now we have to reverse this. If we reverse this, the new state of linked list will be 4 3 2 1. Initially it was 1 2 3 4. Now if we reverse, the last node will become the first node and the first node will become the last node. This is what reversing a linked list is. There are several ways to solve this problem. One easy way is that we can create a new linked list out of this. So what we'll do is we'll traverse this linked list and we'll create a new linked list by inserting elements at the start of the new linked list. So let us say traversing this. So first I'll insert 1. Again I'll insert an element at the start of the new linked list. From this it will be 2, next 3 and 4. So if we see this is reverse of this linked list, right? But in this solution we would need extra space. We can solve this without consuming extra space. We'll use that approach for this problem. Let us try to reach the logic gradually by small steps. So first let us say if we have only one single node in our linked list, single node, no need to reverse, right? Now let us say we have two nodes. We have two nodes, head pointing to 1. I'll take two nodes, 2 pointing to null. So if we reverse this, it will be like 2 pointing to 1 pointing to null. This is head. This is reverse, right? Now let us see how we can do that. So if we see in this, 1 is pointing to null. This 1, which is the first element in this, is pointing to null, and 2 is pointing to 1. So let's try to do the same. What I'll do is I'll take a pointer called current. I'll take a pointer called current. Current will be equal to head. So I'll take a pointer here, and what I'll do, I'll make this point to null because 1 should point to null. But here if I make this 1 point to null, then we will lose this connection, right? This rest of the linked list will be lost. So before making this 1 pointing to null, what we'll do is we'll try to save the rest of the linked list. I'll take one more pointer. I'll call it as next. Which is equal to, this is next of this one, right? Which is equal to current dot next. So now we have this rest of the linked list. So now what we can do is we can make this first node point to null. It means I can make my current dot next point to null. Then now what I have to do, I have to make this one point to 1. That is, I have to make the next. 2 is in the next, right? So I have to make this next point to the first node, and then what I have to do, now 2 should be my head node, right? So 2 is in next. Simply what I can do is my head is equal to next. So if I write the steps, so first what we'll do is before making this first element pointing to null, we need to save the rest of the linked list, right? So what we'll do is first I'll take a pointer that is current, which is initially equal to head. Done. Next before making this point to null, I have to save rest of the list, right? So I'll take one more pointer that is called next, which is equal to current dot next. Okay, now third step, what I have to do? Now I can make the first node point to null, right? How can I do that? I'll say current dot next is equal to null. And now the fourth step is I have to make this node point to first node. How can I do that? This is my second node, next, right? What I'll do is next dot next is equal to current. So now till this step what will happen? 2 will point to 1, 1 will point to null. But where is the head pointer? Head pointer is still at the 1. Head pointer is still at the 1. So we can change that, right? So because head should be the first element, 2 should be the first element. So what I'll do, head is equal to next. Done, right? Next is pointing to 2, right? So 2 will become the new head. This is how we solve when we have 2 elements. Okay. Now let us take 3 elements. Take head 1, 2, 3 and null, right? So now I'll take a pointer. So now what will be the reverse? It will be 3, 2, 1 and 1 pointing to null. If only 2 nodes, the previous logic will work. Now we need to come up with some generic logic which can work for any length of a linked list, right? Now what I'll do, same, I'll take a pointer here, current. I have to make this point to null, right? So if I make this point to null, I need to save the rest of the linked list before that. So what I'll do, again I'll take a next pointer, done. So here I'll take new pointer that is called previous. Okay, I'll call it as previous, which is initially null. Here we need to make this point to null, right? So consider that I'm storing that null in previous pointer. Okay, previous is null. Now let's see. So first I took my current. I'll write the logic here. Here. Okay, I took current which is equal to head, done. Next, after this I have to take the next, right? Next will be equal to, because before making this point to null, point to previous, because null is in previous, right? Okay, before making this point to null, we need to preserve rest of the list. So I'll say next equal to current dot next, done. We have rest of the list. Now we can change this, right? We can make this point to null. What we'll do is current dot next equal to null. Can I do one thing here? Instead of making current dot next equal to null, I'll say equal to previous, because right now previous is storing null. So previous or null, both are the same. So instead of null, I'll say previous, done. Now this will start pointing to null, right? Now what we have to do is I have to make this point to first node, right? So what I'll do, if I want to make this point to first node, I can say next dot next equal to current, right? But here instead of doing that, what I'll do, I'll try to shift the positions. So what I'll do is I will make this as previous. I will make this as current and will repeat the same steps. I'll make this as previous. Previous will not be null, it will be current, and my current will be the next. Next will be this one. I'll just shift the positions. Okay, so now what I'll do, I'll say my previous is equal to current and current is equal to next. Okay, so why are we doing this? If you see here, we are trying to make the current dot next point to previous, right? So initially the value of previous is null, right? Now next step is I have to make the second node point to the first node, right? So instead of making it directly point to the first node, what I'll do is I'll say previous is equal to first node. How can I do that? Previous is equal to current. If I do this, my first node will be in previous, right? My first node will be in previous, and I'll say this as my current node. I'll say this as current node, and in the next step what I'll do, I'll again say current dot next equal to previous. This time this is previous, this is current, so obviously this will start pointing to this. So 2 will start pointing to 1, right? We are trying to repeat this steps, so remove this. Will be using a while loop, will be repeating these steps. Current is head. Okay, I'll take it here. We are trying to repeat these steps. First we'll start from this head. I'll make my next equals to current dot next and current dot next equal to previous. Done. That is one. Again I have to shift the pointers. I'll make my previous as current and current as next. Done. In the next step what we'll do, again before making this point to the previous one, I'll store this. How? My next is equal to current dot next. In this step will be here. Now I'll say my current dot next is previous. Done. We made this. Again my current is next. We'll shift the pointer again. This will be here, this will be here. Previous, this is current. Again in the next step, next equal to current dot next. It means my next will start pointing to null. My next will start pointing to null. So now what I'll do, current dot next equal to previous. Now we'll make a connection from 3 to 2. Again we need to shift the positions, right? My previous will become current and current will become next. Next is null, right? So now current will obviously be null. So where will my previous will be? Previous will be at this position after will be at this position if we keep on doing these steps. It means whenever my current pointer becomes null, it means we have reached the end of the list. It means we have achieved the reversal of the linked list. So my new head node will be the previous, because previous is now at the last node, right? We have made the connections, reverse connections, and previous is at the last node. So at the end what I have to do, I have to make my head is equal to previous. Done. This is how we do. If I write the logic for this clearly, I'll write over here and try to explain it again. First what we'll do, we'll take current equal to head. Done. I'll take previous initially as null. Done. Now I'll take a while loop, because we are repeating the steps, right? We are repeating the steps. I'll take a while loop. Now here first step is before making this pointing to the previous, we need to preserve rest of the list, right? So to preserve that, I'll say my next equal to current dot next. So we all have the rest of the list. Now what we'll do is current dot next equal to previous. Initially it is null, so the first node will point to null. Done. Next we need to shift the pointers by one position, that is simply make previous equal to current. It means previous will shift by one position and current equal to next. Current will shift by one position. Now what should be the condition over here? As we seen here, at the end my current will become null. Initially next will become null, then we'll say current equal to null, sorry, next. So current will be null. At that point we need to stop. So we need to do these steps until and unless current is not equal to null. So at the end my previous will point to the last element of the list. So after reversal, last element need to be first element, right? So how can I do that? I'll simply say head equal to previous. Done. This is the main logic for reversing a linked list. Let's try to code this. Okay, I'll write here public void reverse. Done. So first let's handle some conditions. Let's say if we don't have any elements, we'll simply say list is empty. List is empty. Done. And I'll return. Now let us say we only have one element. If we only have one element, head dot next will be null, right? In that case, no need to reverse. I'll just return. Done. Now after these conditions, I'll take previous, which is null, current, which is head initially. Now I'll take a while loop. First thing is preserve rest of the linked list, that is I'll take a next pointer, next equals to current dot next. This is to preserve the rest of the linked list. Now I'll make current dot next equal to previous. Done. Now I have to shift the pointer's position. Previous will be current, current will be next. After iterations, at the end current will become null. Then we need to stop. We need to do this until current is not equal to null. After these steps, at the end previous will be pointing to the last node. It means last node will have to be the first node of the reversed list. So what I can do is say head equal to previous. Now head will point to the last node, which is the first node after reversal. Done. Now let's run this. So here we have four elements. I'll say list dot reverse. Run this. Okay, I'll print this display. So if we see, we have inserted four elements and displayed 10, 20, 30 and 40. We have called the reverse function. This is in place. Reverse the linked list in place without consuming extra space. So if I print the list again, it is 40, 30, 20 and 10. So this is how we'll reverse a linked list. That's it for this video. And thanks for watching. If you like this video, hit the like button and subscribe to the channel. Thank you.